I'm Grundy. I'm going to talk about our work on building an empathetic approach to human-centric requirements engineering using virtual reality. This work's done with a number of my students, Nicholas, Manuel, Adrian, Sienna, Sarith, and Jim, and with PhD students, Ben and Yi, and Thong Hai. Hi, I'm John Grundy. I'm going to talk about an empathetic approach to human-centric requirements engineering using virtual reality, done with a number of my students and one of my colleagues. First of all, I'll talk about the reason we're undertaking this work. I'll talk about the virtual reality environment we created for human-centric requirements engineering, key research questions that we wanted to answer in this work, our approach, results, conducting a study of our tool, some discussion around the benefits and limitations of the approach that we've developed, and a brief summary of the talk. Software engineers are typically quite different to many of the end users. For example, most are male, most are quite young, most have a high socioeconomic status, high education level, they have relatively limited physical and mental challenges compared to many others in the community, and so on. Software engineers often struggle to address the needs of many diverse users, including neurodiverse individuals, such as those with ADHD. We developed a virtual gym environment and added some simulation of sensory, auditory, and visual distractions associated with ADHD. Now, the idea was by using this virtual reality environment, software engineers could better understand and cater to the unique requirements of ADHD users when designing software. Now, there are many challenges of capturing requirements from diverse users, and it can be very difficult for software engineers to put themselves in the shoes of these users. Virtual reality was a tool that helps elicit empathy, enhance understanding in different areas, including in requirements engineering. ADHD has a number of different impacts on different people, but commonly inattention and hyperactivity or impulsivity are quite common. And these can affect various functionings and development. Now, most engineers are neurotypical, with a very small number neurodiverse, including with ADHD. And this lack of diversity in engineers contributes to a lack of understanding and carrying out human-centric requirements engineering for those with ADHD. Previously, we developed a VR environment to help capture requirements. The example we used was requirements for a gym app, and we used this to develop a prototype gym app after immersing software designers in the virtual reality environment. I wanted to extend this approach to try adding some additional features to simulate some of the impacts of ADHD that ADHD often has. So we focused on exploring virtual reality to aid software engineers in understanding, particularly users with ADHD, how that might impact their requirements for using a gym app. And we wanted to understand how this might give them a better understanding of different viewpoints and challenges of diverse end users. In this particular case, how VR could help in human-centered requirements engineering by developing a more empathetic approach. We also wanted to find out if VR could help in designing better solutions. So could our VR prototype help software engineers come up with better solutions for a gym app for those with ADHD? The process we went through, we developed a virtual reality environment, previous work. Participants wear VR headsets. They start a exercise in the gym. They carry out a number of repetitions, doing different kinds of exercises to work out different parts of the body. And then what we want to do is introduce some distractions. So this included visual distractions and audio distractions. The visual distractions could impact the environment, particularly in terms of clutter or distracting visual occurrences. Similarly, audio distractions could impact the environment, different audio distractions. To give an example, here's some clutter added to the VR environment that's visually distracting, depending on size and color and shape and so on. Audio could be things like music or announcements, people carrying out exercises, gym equipment, and so on. Then, after building our virtual reality environment with ADHD or limited aspects of ADHD simulation, we recruited 13 participants, mostly male and mostly relatively young. Most of these are students who were involved in IT courses. 2 of them were working in industry, and 6 of the participants had various industry experiences. It's a relatively small number of new people with clinical diagnosis of ADHD, but none of the participants had ADHD themselves or had been diagnosed with it. We carried out a pre-questionnaire to find out some knowledge or lack of knowledge about different ADHD impacts, and you can see the results here, that prior to the VR simulation study, the participants had pretty limited knowledge about ADHD impacts or potential impacts on end users of software. We also asked about how ADHD might impact people in terms of everyday life, accessibility of software, performing tasks in software, and when these participants themselves designed software, did they consider ADHD impact on end users? Again, as you can see, most of them had fairly limited understanding of impacts, and only a moderate amount of concern when eliciting requirements for potential for users of ADHD in their own software designs. After they used our VR environment, where they went through a number of tasks, they experienced a number of visual and audio distractions to simulate ADHD impact, then they identified that intellectual inadequacy is not a symptom of ADHD with a higher degree of accuracy. They also were far more aware of some of the kinds of impacts that having ADHD might have on people in a gym trying to use a gym app. They also incorporated some of these ideas into the requirements that they would need to consider when designing such an app. Some of the positive findings we had were that the VR experiment that we had the users carry out did seem to assist them with understanding some of the impacts of ADHD and how it might impact them in a gym environment. We also made it aware that the accessibility issues for people with ADHD might not be as good as previously thought and might be quite different to other kinds of accessibility challenges. They also expressed to us that they had a greater understanding of how performing various tasks in a software application, such as a gym app, under the influence of distracting visual and audio cues, it could be very challenging. However, the experiment also had some interesting outcomes in terms of impacts on everyday life. And while there's an increase in participants thinking that the impact could be important, the results were somewhat inconclusive and would need to be clarified in future studies. There was some feedback given by participants about improving our tablet-based gym app to try and better support ADHD users. Some interesting implications, the fitness level of the participants and the frequency of going to the gym seemed to have some influence on the results. The video distraction was not very effective that we used, but abnormal object movements were more distracting. So some more relevant distractions would be needed in future. And we thought we'd need more expertise around those kind of distractions, how they actually manifest from experts in the field. So the audio distractions, it was impactful, but some found it more annoying than helpful. And some further refinement of this would be needed in future as well. We used an interpersonal reactivity index to help measure empathy, and the overall scores measuring empathy did improve, and they would generate expected levels. So a greater proportion of our participants in the end recognized ADHD challenges in the experiment. We found that VR did help with some eliciting of empathy around end users with ADHD, and there are a number of threats to validity that would need to impact future studies. The number of participants, difficulty of the exercises, gender representation, and more expertise in ADHD. So we need another ADHD expert on the team. We need to look at some improvements in the VR environment around mobility, and to look at simulating other ADHD symptoms. Overall, virtual reality can provide an empathetic approach to requirements engineering, help engineers design better solutions, and encouraging further research in the area. Thank you very much for listening. Hope you enjoy our paper.